Good afternoon, everyone. Welcome to the latest webinar in the Nature-Based Solutions, moving the conversation from theory to application with the LA Waters Programme and the Department of Housing and Local Government Heritage. I'm Finola O'Driscoll. I'm a Senior Programme Manager in the National Transport Authority. And it's great to I'm delighted to be able to host this webinar. We've got some great speakers. This session is about detailed design. So I think last week was more about plans. We're moving into more towards the application, and we've got some great speakers. We've got Pádraig O'Gorman, who's the director in Carlow County Council, talking about integrating nature-based solutions into some of their housing projects. We've got Aidan and Alan from Mont MacDonald talking about bioretention on a primary road in a rural town. And we've got Conor, Geraghty from Dunleary about building nature-based solutions into active travel schemes. So I'm going to introduce Pádraig. Pádraig graduated from Dublin City University with BBS in business studies, and later at UCD MBS in business studies. He's over 25 years local authority experience. He's currently Director of Services with Carlow County Council, which includes responsibility for the delivery of infrastructural projects, roads, active travel, URDF, special capital projects. So he's the he is the exemplar. If you want something done, ask a busy person, because I think he's presenting a few presentations as a part of this series. He's also got responsibility for environment and climate action brief, and he's been promoting the assessment, development and implementation of nature-based solutions into the capital works projects of the councils. So I'm delighted to introduce Pádraig.
And good afternoon. So by way of introduction to this item, I suppose to give a bit of background to it, I suppose over the last few years with attending, I suppose, webinars like this, conferences, a lot of subcommittees that our staff would be on, I suppose the whole concept of nature-based solutions has been raised and presented. We had been researching into them, and the detail coming through. But a lot of the detail was in relation to examples that was maybe EU based or UK based. We had a cross-functional team meeting ourselves here in the council, and basically I'd asked the engineers mainly, had we got a nature-based solution for any of the works programs that we have? And like many local authorities and other public bodies, we have a substantial number of projects in the pipeline and coming into design. We've a substantial URDF, urban renewal project for Carlow Town, active travel, the roads programme, various public realm enhancements, and obviously the housing programme. So we didn't really have anything. We were basically, doing conventional surface water solutions. So I asked the team to go and have a look at possible, nature-based solutions that we could integrate into one of our projects. And basically, what we really needed was to get a demonstrator nature-based solution on the ground here in Carlow to kind of see what was involved in designing it, the cost of installing it, and then as a demonstrator as to how it actually would work. If we move on to the next slide, please. So our housing engineer, Lily Sly, and our area engineer in that area, Pat Harrington, came back to us with a solution, nature-based solution for a social housing development that we had in Rathvilly, which is a large village in North County Carlow. It was a problem site from a surface water perspective, and basically when you would have flooding and that, the actual infrastructure in the village would sometimes become overcome from a surface water perspective. So to be able to find a nature-based solution for the site would be a big advantage. So it was 4 elements that they went away and came back with in relation to the overall project from a nature-based solution perspective. One was the introduction of a swale. The second was a single-tiered vegetation storage area. The third was a rain garden. So just kind of the swale is in this area here, if you can see the cursor moving. The single-tiered storage area is here in the main area of the site. The rain garden is over here, and a series of tree pits then here to put in. So one of the main points I want to get across today is that this was designed in-house. So our engineers went away, looked at various material that had become available, that were there in recordings, through webinars, the various contacts that had been circulated to them. And from tic-tacking and feedback with those contacts, we're able to get the information, the detail, the technical specifications, and feed it all into those 4 elements, which combined create the overall nature-based solution for this social housing development, which originally was for a 10-house scheme and is currently now has been upgraded to an 18-house scheme. Next slide, please. So the first element of it was to have the single-tiered vegetated storage area. And basically this involved creating a tiered existing ground level, selecting a number of plants that can tolerate occasional submersion and wet soil to be planted in the area, and also then a reed planting area. So pretty straightforward, and the detail of that was readily available. Next slide, please. I suppose the main feature of it then was the actual vegetated swale. So again, the detail all available in relation to the base that is required, the level of topsoil, the specification for stoning, draining, and then the actual vegetation to be used both on the slopes of the swale and the rounding of the swale, and the various planting then to be in the actual swale itself. So again, over a period of time, they had tic-tacked with the various contacts on relation to getting that information and determining the proper solution for this site in relation to that specification for that swale. And next slide, please. This was the rain garden then over to one side of the site. Again, selected the various specifications that were required, and in-house they contacted our town gardener, Michael Buckley, at the time, and Michael came up with the range of plant species that should be put in that would assist, that would be suitable to maybe more wet ground conditions. So he came up with those varieties and incorporated them into the overall design for the scheme. Next slide, please. The 4th element then for the nature-based overall solution was the tree pits. And while this slide looks quite simple, there actually is quite a bit going on here. So we have, first of all, detail in relation to the positioning of the specification of the trees. And this is in accordance with DMORS. Also specification there in relation to, depending on what species of tree is selected, the proper spacing for it so that it can reach its full potential and maturity. The design shows here that from the roadway that basically excess water can get into the tree pit, and over here then also a drain so that the actual tree pit doesn't become waterlogged, which would affect the root growth and the growth of the tree. Or doesn't allow for road salt to be deposited and kept into the tree pit. So while it looks a simple design, a lot of detail went into the proper design of it so that you have a proper, effective, functioning nature-based tree pit. And next slide, please. We got a lot of feedback as we went through it from tic-tacking with our colleagues on that. I had mentioned there about the varieties of in the rain garden, the varieties of the plants that were used, and it had come back to us from some of our contacts that 1 or 2 of the varieties may not be fully suited to a nature-based solution because they might be more suited to dry conditions. So we changed those. And here in relation to the swale itself, again, we got good feedback in relation to the vegetation heights that should be used on both the slopes of the swale, the rounding of the swale, and in relation to the height that the plants should be allowed grow to on the swale. So A lot of very, very good help, assistance, feedback was available as we developed the overall concept and project, and a lot of good feedback came back to us that we then amended and fed into the final design and the 4 elements that I have outlined. Final slide then, please. So in summary then, what I'd say is from our perspective, we started from a relative blank page, basically from attending webinars like this, and whereby there was presentations about nature-based solutions. That, I suppose, whetted our appetite in relation to what was all this about. Could we develop a project? From sitting down with our own in-house team, we hadn't really started with developing anything in a nature-based solution. We agreed we very much wanted to have a demonstrator project, and I asked the staff to go on and could we develop one. And there was a very strong willingness from the staff to engage, learn, develop a nature-based solution. And I suppose what was interesting then was that the first one that we came up with to feed into a detailed design happened to be a social housing project that we were developing at the time, and which is the plans that we now have presented. There was an awful lot of advice, assistance and information available through a range of sources, webinars, conferences, recordings, the internet, Law Pro, etc. And a lot of people came back to us once we knew we were working on a project and asked, could you send on details of it, and give, as I said, their expertise to help us shape the final design and elements of it. 2 important points is that it was designed in-house, all 4 elements, so it was very much cost effective. It didn't involve having to go outside of our own engineers who gave up their time to go and research what was required and what would be effective and what would be a proper solution. I think it's important also to note that the nature-based solution that was incorporated into the plans is cost neutral when compared with a conventional solution. And this was something that we put down as a prerequisite because, like most public bodies, our funding is coming external, and we had to be sure that what we were putting forward to our funders wasn't going to be seen as an excess cost or an excess expenditure on delivery of a project. So that was an important prerequisite that I feel we put down at the start. As I said, it was a surface water problem site, and this nature-based solution that our engineers forwarded addresses that, and it overcomes the surface water infrastructure issues that were in the village. We've had no issues from the Department of Housing as yet on this solution that we've put into this social housing scheme. It went through stage 1, it went through stage 2. It's currently at stage 3 pending approval. We expect to have that in the next couple of weeks. That will allow us to issue the full scheme, 18-house scheme, with this nature-based solution out to tender, and will currently be programmed to be under construction later this year, and completion of the project next year in 2024. So I suppose finally then, just the immediate benefits is that it deals with a surface water problem that we had on the site and in the infrastructure in the village. It will greatly enhance and improve water quality in the area. There's biodiversity aspects to it, improve climate action, and it hopefully will deliver for us the demonstrator project that we want to have on the ground here, so that we can, as I say, learn from it, improve on it, and build it into the design of other public realm infrastructure, roads, active travel, urban regeneration projects that we have in the pipeline. We also then, just as a side, we also have installed a bioretention rain garden in Carlow town, which is up and running and is effectively working, and we'll be doing a short presentation, I understand, on that next week. So thank you very much.
That is great, Pádraig. What a fantastic example of just pragmatic thinking and can-do attitude, and let's get this together. And yeah, very reflective of our dealings with Carlow as well. Absolutely pragmatic local authority, just want to get things done, which is great. So yeah, I'm sure there'll be lots of people asking for those drawings and specs and stuff like that, and that'll all be available, guys, on the website. That's great. And Pádraig will be here later on question and answer session if you've got any more questions. I'm just going to introduce now together Alan Costello and Aidan O'Connell from Mont MacDonald. Alan's a chartered engineer with 17 years experience, including national road schemes, urban roads and sustainable mobility projects. He's developed technical expertise in drainage and road pavement design, and his current responsibilities at MacDonald include delivering projects to a wide variety of public sector clients. And Aidan is a civil engineer with 10 years experience, also worked on lots of roads and wastewater and urban road improvement schemes. And he's also developed technical experience in drainage design. So I think it's Alan kicking off,
Yep.
going to talk about bioretention systems on the N74.
Thanks, Finola.
Thanks, Alan.
So good afternoon, everyone. And thank you to Fran and Avril for the invitation to speak today. Our presentation will be looking at using nature-based solutions on a road scheme, specifically bioretention systems to manage surface water on the N74 National Primary route into Tipperary Town. So as Finola just mentioned, my name is Alan Costello. I'm a senior associate with Mont MacDonald, acting as a project manager in the transportation section. I'm also the development manager for the Irish business. And my colleague Aidan O'Connell is a civil engineer with expertise in drainage design. And Aidan was the lead designer for the N74 scheme. So I'll just give a brief overview of the N74 and touch on the drainage strategy that resulted in the use of bioretention systems. And then Aidan will go through the more interesting parts of the presentation, which look at the design and specification of the bioretention systems, the stakeholder interactions involved, and he'll cover some of the opportunities and the considerations with incorporating nature-based solutions in a road scheme. So the N74 scheme is located on Father Matthew Street and the Cashel Road in Tipperary Town, and it commences at the 60 kilometre an hour speed limit and finishing at the Banter Road roundabout where the N74 meets the N24 primary route. So the scheme is about 1,200 metres in length, but it represents a typical entrance to a rural town, which is rural at the outset, then transitioning to a residential area, and then finally connecting to the urban core. So it is quite a good scheme in terms of its representation. So the scheme was developed to address a number of issues that were known to our client, Tipperary County Council, and the funding authority, which is TII. The first related to road safety. So the collision data indicates that the collision rate is above the average collision rate, primarily due to poor road layout along the street. A significant feature of the road layout is the lack of quality pedestrian infrastructure with poor linkages and difficulties crossing at junctions, as you can see in some of the photographs there. Another feature of the existing road layout is the informal parking that takes place along the street, which impacts the passing traffic, but also pedestrian movements. So the pavement surface is also quite poor and in need of intervention. And there's a noticeable lack of quality green areas and landscaping along the street. Finally, the existing drainage system was in need of renewal, and we'll look at this in a little bit more detail later. So to address those needs, the scheme objectives aim to address these in a holistic and a coordinated way. The first major design decision was to reduce the road width in accordance with DEMER standards to 6.5 metres and then transitioning down to 6 metres. So this opened up a whole host of opportunities because it allowed us to reallocate road space to improve the pedestrian infrastructure, formalise the on-street parking for residents, but probably most importantly for today's presentation, it allowed us some space to incorporate some high quality landscaping treatments and then nature-based solutions. So why specifically bioretention areas? So there was a couple of features of the existing drainage that we needed to address. It was an existing combined sewer, which experienced surcharging during extreme rainfall events. So any intervention that we went ahead with needed to improve the drainage capacity of to the existing network and trying to relieve some of the hydraulic loading downstream. Secondly, we wanted to incorporate some solutions which dealt with the first flush where possible to improve water quality. The scheme had already committed to incorporating some high quality landscaping treatment where the road space is being reallocated. So there was an opportunity there to incorporate nature-based solutions in those areas. So referencing the available guidance, just some examples there on the left, and utilising experience within Map McDonald and other similar road schemes, we proceeded to incorporate bioretention systems, which have a lot of benefits. The first being that it improves water quality. They also provide attenuation to the drainage network, maximise biodiversity benefits, but also they replace hard engineering solutions with a SUD solution. So my colleague Aidan now will take you through the bioretention system design and some of the stakeholder interactions that we had.
Perfect. Thanks very much, Alan. I'll just share my screen there now. The main question probably some of you have are, what actually are bioretention systems? Bioretention systems are shallow landscape depressions that can reduce runoff rates and volumes and treat pollution through the use of engineered soils and vegetation. As you can see on the screen, there is a typical schematic of a bioretention system, and I will give a general description of each of the elements of that system now. The inlet, vegetation and extended detention areas are located on the surface of a bioretention system. The inlet allows surface water runoff to enter the bioretention system, and the inlet should ensure that scouring and erosion of the receiving soil does not occur. Vegetation is a very important aspect of the system, as it acts as a pollution control. It also prevents erosion of the surface soil layers and helps maintain permeability of the filter medium below. The depth of extended detention, which is also just on the surface, temporarily stores water on the surface that requires treatment and provides some attenuation. Next, I will go through the main engineered soil layers, which are the filter medium, the transition layer, and the drainage layer. The filter medium filters out pollutants and controls the rate of which water filters through the bioretention system. It is typically sand-based with some organic matter to maintain the healthy growth of the vegetation on the surface. Below this then is a transition layer, which prevents washing of fines from the filter medium above into the drainage layer below. The drainage layer then collects water from the filter medium and allows it to reach the perforated pipes at the bottom of the layer. As I just mentioned there, a perforated pipe is located at the bottom of the drainage layer, and this collects filtered water that passes through the system and conveys it to the drainage network. As well as all this, an overflow facility is required to direct flow downstream if the volume of the bioretention system is exceeded. In relation to the location of the bioretention systems on the N74 Father Matthew Street project, due to the upgrade and realignment of this scheme and the carriageway, areas for landscaping were created between the new carriageway and the footway. And it is within some of these areas that we have cited the bioretention systems. The proposed locations of the bioretention systems with regard to the carriageway cross-section are shown in blue on the slide on the left. And then the areas that were kept as low-level planting are shown as green on the same slide. The landscaped areas chosen for use as bioretention systems were ones which weren't too narrow and but also had substantial area to receive surface water runoff. The detail on the right then shows the typical location of the bioretention systems that we prepared in relation to the carriageway and the carriageway's associated curbing and the footway and the footway's associated curbing. This bioretention system detail is what we developed as part of the N74 Father Matthew Street Road Improvement Scheme, and I will go through the detail of each of the elements of our design in the following slides. The main, as I mentioned earlier, the main items on the surface of the bioretention system are the inlet, extended detention, and the vegetation. The inlet of our bioretention system comprises of 650mm inlet, or 650mm wide gaps in the curbing to allow surface water to enter the bioretention system. Just inside the inlet, granite aggregate sets are located to act as a sill trap. these sets also slow down runoff entering the bioretention system to prevent scouring of the soil within the system. The extended detention depth is specified as 100 millimeters in our system. The vegetation on our system has been specified by a landscape architect for specific use within a bioretention system. What I mean by this is that they are specified for use in times of drought, as well as when the area is saturated. And the general type of planting specified for our system is water-tolerant herbaceous and grass perennial species. The main engineered soil layers are the filter medium, the transition layer, and the drainage layer. A 700 millimeter depth of loam soil comprising of 45% sand, 35% topsoil, and 25% compost has been specified for the filter medium. This composition was specified to allow flows to dissipate into the lower layers, but also to control the dissipation of water through the layer. And what I mean by this is that so that the water doesn't filter down through the filter medium too quickly. The element of organic matter then within this layer is to provide nutrients to the vegetation on the surface. Below the filter medium is a transition layer, and this has been specified as 100 millimeters deep and is made up of clean, well-graded sand with less than 2% fines. And this is in order to prevent fines from washing from the filter medium above into the drainage layer below. Then underneath the transition layer is the drainage layer. And this is proposed as a minimum of 150 millimeters in order to provide sufficient cover to the perforated pipe within it. And this is type E filter material. Our bioretention system has not been designed for infiltration. Therefore, the drainage layer is sloped towards a perforated pipe on drain, as shown on the image on the screen. As well as this, because our bioretention system hasn't been designed for infiltration, an impermeable geomembrane is also proposed around the bioretention system. I suppose they're the main engineered soil layers. As well as these, there are some pipework and other items associated with the bioretention system. As I mentioned in a previous slide, the drainage layer is sloped towards a perforated pipe under drain. This perforated pipe collects the filtered water that comes down through the filter medium transition layer and conveys it towards a gully pot at the downstream end of the bioretention system. This filtered water is then conveyed from this gully pot to a dedicated surface water drainage network within the carriageway by means of 150 millimeter diameter gully connection pipework. The gully grating at the top of this gully pot also acts as an overflow in situations where the volume of the bioretention system is exceeded. And as well as this, along extended lengths of bioretention system, overflow hoppers are proposed which collect any water in an overflow scenario and discharge it into the perforated pipe, which then conveys it onto the surface water drainage network. They're the main elements of our bioretention system, and I will speak a bit now about the stakeholder interactions that took place during our detailed design. The main stakeholder interactions with respect to the bioretention systems were with TII. Firstly, there was close communication and consultation with a TII landscape architect at an early stage to establish a landscaping strategy, and with the hope of promoting opportunities for nature-based solutions, which were actually then incorporated into our detailed design in the form of the bioretention systems. As well as this, as a rule, TII Road Safety were informed of all design developments, including the bioretention systems, and comments were welcomed from this team. TII publication Drainage Systems for National Roads states that the drainage arrangements permitted on national roads, which our scheme is located on, I suppose it states what the permitted arrangements are on national roads. As bioretention systems are not included in this, a departure from standard was required to permit its use on the N74. Early interactions with TI landscaping and road safety, as mentioned above, fed into the departure application, which helped the process of preparing the application. This departure from standard was submitted to TII and was accepted. As well as the interaction with TII, there was some interaction with the utilities on the scheme as well. The N74 for the Matthew Street is heavily congested with services. Therefore, as part of the detailed design of the overall project, diversions of ENA communications and water main in consultation with those providers were required. These diversions were kept away from the bioretention system as much as possible to avoid possible issues arising down the line, and I'll touch on that on the next slide. In relation to the opportunities, it is very important that nature-based solutions opportunities are identified, promoted, and adopted at an early stage during consultation with the relevant project stakeholders. When this is carried out, it makes the introduction and the application of nature-based solutions into detailed design much more straightforward when it comes to the detailed design. On our scheme, during the detailed design of the bioretention systems, it became very evident that a multidisciplinary approach was key to incorporating these systems into the road improvement scheme. These systems can't be designed or sited in isolation, and it is we found that close coordination between drainage, landscaping, and road design teams were required to ensure that the opportunities for nature-based solutions was maximised. Interactions between the bioretention systems and utilities is a big consideration to take into account, as extensive consultation with the provider is required where utilities are located within the bioretention system. However, this is a consideration that can be managed in the process of including these systems. Where utilities do interact with bioretention systems, the utility provider needs to have an understanding of the reinstatement arrangement of the system, when or if the utility may need to be exposed, and the bioretention system would need to be reinstated. Monitoring will be required to ensure that the bioretention system is reinstated appropriately. An important point to take from this is that there are some considerations to incorporating bioretention systems, such as the requirement for departure from standard and consultation with relevant stakeholders, but these are very much manageable when addressed at an early stage of the process. Thank you for listening, and I'll hand you back to Finola.
Great, thank you. That was great, guys, and lots of detail there. And I know lots of people that are listening in want the detail, they want the dimensions, what will fit. Our final presentation, who's from Conor Geraghty from Dún Laoghaire-Rathdown. Conor is a senior engineer for active travel in Dún Laoghaire-Rathdown. He joined DLR in 2008, worked across a number of departments on the delivery of public infrastructure. He's responsible for many of the interventions rolled out in Dún Laoghaire, the many interventions rolled out in Dún Laoghaire over the last couple of years, including the coastal mobility route and public realm award-winning public realm schemes like Monkstown Village Improvement Scheme. So Conor's going to talk about nature-based solutions as part of the DLR Central project. Thanks, Conor.
Thanks, Finola. Good afternoon, everybody. Yeah, as Finola said, I'm senior engineer for active travel. And the scheme that I got to primarily focus on today is the DLR Central scheme. So it's just little over 3 kilometre scheme that's in the urban area of Dún Laoghaire that connects from one corner of most of the urban area within Dún Laoghaire across 5 very large signalised junctions. So the existing situation is quite traditional in its approach to road infrastructure: multi-lane crossing points, staggered crossings or segregated crossings for pedestrians, slip lanes, and very wide carriageway space. Similar to maybe some more traditional road schemes, it's dual carriageway with an almost entirely impermeable surface from wall to wall, with no planting and no infiltration or nature-based solutions along any of it. So the challenge that we had within this scheme, or maybe the primary objective of this scheme, was to provide and retrofit active travel facilities into it. That's obviously as the NTA focus at the moment, to try and get more people to walk and cycle. A secondary objective was to improve public realm, to include things like seating, to align with age-friendly policies, to provide incidental play, which is kind of play facilities along the length of the route rather than designated playground facilities. We obviously, with areas like this that are so heavily paved, where there is an impact on the drainage systems and there are flooding issues in the area. So the scheme has an objective to reduce that, and obviously to align with our climate change objectives, which includes increased planting and providing active travel facilities. So this scheme had to go through Part 8, which is the statutory planning process for local authorities. So within that, our own drainage department require a drainage strategy in advance of any planning, any plans being submitted. We also have to provide a landscaping strategy. So at the very earliest stage of the project, we were thinking about how best we could incorporate SUDs and nature-based solutions into our scheme. When it comes to active travel projects, it can be quite a challenge sometimes to deliver these schemes, particularly when people are, or when you're suggesting reallocating space from one mode to another. And there's some word associations that we did as part of a survey. And it's quite interesting that pedestrians are generally seen as being vulnerable and slow and careful and sustainable and friendly and nice, which is not surprising because everybody's a pedestrian and they're less likely to be critical of themselves. Whereas when it comes to cyclists, they're perceived as being fast, rule breakers, reckless. So there's an element of toxicity that comes with the idea of cycling and cyclists. And when you're trying to reallocate road space to that mode, it can result in a lot of negative feedback. So it's also worth mentioning within Dún Laoghaire that 46% of people surveyed said that they had no interest in cycling, regardless of what facilities were provided. That doesn't mean they would object to providing for cyclists, but just that they were not interested in cycling. So within these type of projects, if you're trying to deliver large-scale mobility changes, nature-based solutions can add a real benefit to the project, where people that aren't interested in cycling or maybe not all that keen on cycling can see the value if they support a scheme because they get much nicer places to live. So this slide is one of the kind of early concept discussions that we had about how to deal with surface water within the project. So on the kind of green hatching towards the bottom, we were considering permeable paving along the length of the cycle track. The northern section is an area of green space where we were looking at attenuation facilities, underground attenuation facilities. And it's an existing green space parallel to our project, but it's incredibly underutilized. Residents don't tend to use it that much. There's no paths through it. It's grassed. You would get an occasional person walking the dog, but otherwise it's an area that's not being used. So looking at the drainage strategy, one of the early things we identified is the need for an underground attenuation facility. And on top of that, knowing that we had to develop or be carrying out works in the park, we started to think about how do we reinstate it, and looking at things like adding pathways through the green space to try and enhance it, new planting, active travel, incidental play facilities, and things like swales and retention areas. So the scheme that went to Part 8 had included for new paths through this area, and this is all on top of the attenuation facilities that are underground, new tree planting, swales, retention areas, and then incidental play features. So the existing cross section of that green space is quite bland. There's not a whole lot in it other than some tree planting. So what's proposed then is, areas of meadow planting, new footpaths, mounds and swales, and it'll give a lot more character to the area. And the support then that you get from that is people see the value of the project because they're getting all these extra facilities close by. When it comes to junctions and the road layout, these lines just show the existing situation for people walking. I think it's an 8-stage crossing as a pedestrian. So if you were trying to cross from one side to the other, it could take you up to 15 minutes to cross all these side roads if you were to go with the lights. So the scheme that was designed was essentially reducing the carriageway width, removing slip lanes and turning lanes, and then to provide segregated active travel facilities through the junctions. So that allowed then for the inclusion of these green strips. And the benefit to that for active travel is that it provides that horizontal segregation from the carriageway, but it also then gives us areas that we can use and we can design for either bioretention or tree planting or some other greening of the area. So you can see the photograph on the left is the existing layout, and what's proposed on the right is obviously much nicer for those walking and cycling. On the opposite side of the road, the tree planting then does provide noise barriers and more pleasant areas for the people living on the other side. So there is a value to them supporting the scheme. One thing to mention about about adding kind of green planted strips at the road edge is that they can help you to deal with quite tricky level differences. So this cross section is the existing road profile is in green, and the proposed road upstands on the curbs are in blue and orange. So when you're retrofitting schemes, you would obviously like as much as possible to not have to re-profile the existing road or have to dig up as much of the carriageway. So you're trying to minimize that, particularly in the situation at the moment where everything is so expensive. So allowing or maintaining a footpath of a 2.5% crossfall and providing a 2.5% crossfall on the cycle track, we're able to use the verge in the planted area to deal with a kind of a level issue. So there is nearly a 4% drop from the road edge to the cycle edge, but the planted area deals with that level difference. And what that means then is that we can leave the existing road profile on the rest of the carriageway. So having these planted verges really does allow flexibility to, build things much quicker and cheaper, even though there may be a cost associated with them when you're installing them. So within this project, including nature-based solutions from the very start, did facilitate and allow the segregation of the active travel facility. It included public realm and facilitated incidental play. It's achieved our objectives and reduced the impact on drainage systems. So when we went for part 8, there was about somewhere between 200 and 300 submissions, and we had about 78% positive support for the scheme. And a lot of that is relating to the benefit that people saw from the softer side of the planting. I'm just going to cover another few schemes that we've done. This is one on the west side of the county on Lower Kilmacud Road. So this would be similar to a lot of areas where you can see a lot of illegal parking. These areas used to be grass verges, and they were over time removed and replaced with paved areas so people could park. And what was installed was planted strips to provide horizontal segregation to the cyclists. And on the right-hand side of the road, as you're looking at it, there's virtually no illegal parking anymore. Whereas on the left side of the road, there is still some illegal parking. You can see them there in the background, and they tend to park on the grass. It's quite interesting that people tend to value these more advanced planting schemes much higher than grassed areas. So we don't get any illegal parking in them, where people don't drive over them. Whereas on the grassed areas, there's still, people parking illegally on them. So there is a benefit, and the public do accept that there is a benefit to these, and they value them higher than normal grass planted areas. When it comes to side road junctions, we have an objective in our development plan now that all side road facilities should be continuous. This is a continuous path and cycle facilities across the side road. And I'll go back one, that's what it was previously, which would be a very normal junction layout. So in these type of facilities, there is generally an upstanded curb, and it tapers out to nothing over quite a short period of time. And if this area wasn't planted, you would have to provide some sort of a bollard or maybe even a barrier there to stop cars cutting the corner. And generally that's an issue more on the exit than the entry. But planting the four corners of these junctions allows for the additional water runoff to go into the areas, but also it removes the needs then for more bollards or more harder measures. And it also adds visually appealing facilities to the four corners. There's a scheme on the Rock Road just near the boundary with Dublin City Council that's currently under construction, and the existing median in the carriageway is just this paved surface that provides no real benefit. So as part of the scheme, we retrofitted and we just removed all the cobbles and retained the existing road edge curb and created this sort of a retention area for water. And we put slots in the curb along it. So there are 100 mil slots every 3 or 4 meters to catch surface water. So it's not a huge retention area, but it does allow the enhanced visual entry point into the park, but also adds as a surface water attenuation area. Further along the Rock Road, there are a fairly standard detail at side roads again, where there's it's dished for the down into a ramped crossing. And similar to Lower Kilmacud Road, we're retrofitting continuous path crossings along all of these areas. So this is a new precast curb that we're using to provide the transition up across the footpath. And these are the areas that have been excavated for the rain gardens on the four corners, similar to the Lower Kilmacud Road. And they help deal with this transition so that people don't walk or try to walk across this area and potential trip hazards, but also reduce the level issues to the cars turning left. So these areas have to be planted yet, but that's what it looks like along the footpath now for pedestrians, and the 4 corners then that are barriered there in that photograph will be planted up in the coming weeks. So Finola, that's all I have. So I'll hand back to you.